Hello, sir. I'm here to discuss the one of the object-oriented programming language technique, which is inheritance. So let's start the discussion. As you can see, inheritance is basically a mechanism where a new class that can inherit properties, which is attributes or methods from an existing class, which we also call base class or superclass or a parent class, indicating that a subclass is a specialized version of a superclass. Moving further, inheritance is basically used to enable the code reusability, extensibility, and polymorphism. As you can see that polymorphism is one of the techniques of O programming language, but polymorphism is impossible to achieve without its key element, which is inheritance. So inheritance basically enables the objects of different classes can be where different classes can be treated as object of a common class, leading to ambiguity, which is a problem that we will discuss in our further discussion. Then we have code reusability. Inheritance basically enables or promotes the reusability of a code by allowing to create a new class that inherit the characteristic of existing class, which is parent class. Extend, extending the functionality of a class by adding new attributes and methods in a subclass while inheriting the existing ones from a parent class. Let's see an example code for that. As you can see that we have a parent class called vehicle, then we have a class called car. Parent class vehicle has a method called drive, which prints the string to objects. Then we have is now driving. These objects will be replacing the input given by user. Then we have car. Car has method called honk. String Same type of string is being passed to objects. Then we have is honking the horn. As you can see that when we call the class, and we could see that we have inherited method in a car class, so both of methods are being used by one class, which is car. So we passed input as well, Toyota and Camry, and we will see the output in here. As you can see that we have an output called Toyota Camry is now driving. As we given the input, Toyota Camry is honking the horn. So both methods have been implemented in here by one class, child class only. Moving further, we have types of inheritance: single inheritance, multiple inheritance, multi-level inheritance, hierarchical, and hybrid. Single inheritance basically is a type of inheritance in which subclass inheritance inherits from one class only, one base class or super or parent class, as we did in our last example code. Then we have multiple inheritance, in which subclass can be inherited from multiple superclasses or parent classes, but this type of inheritance is not supported by all programming languages, whereas Python does support it and Java and C Sharp does not, but C Sharp can achieve multiple inheritance by using interfaces. So then we have multiple inheritance, in which a subclass inherits from another class, creating a chain of inheritance along with the parent class. Then we have hierarchical inheritance, in which multiple subclasses inherit from one single parent class. And then finally we have hybrid inheritance, in which a program will have combination of different types of inheritance being implemented to run the program. Moving further, we have faced multiple problems while implementing inheritance. As we can see, we have inappropriate inheritance, uh, it in which the implementing inheritance determine the correct sometimes it's challenging to determine the correct hierarchy, which also leads to poor design choices, for which we have an example. Let's consider an example here. We have a class hierarchy representing different animals, but hierarchy becomes unclear when we introduce a new class subclass called penguin. Well, in this case, the penguin class inherits from a bird, which implies that bird can fly. This is an improbate inheritance type since penguins are flightless birds. Moving further, we have tight coupling, which create in which the inheritance implementing inheritance can create tight coupling between classes, which makes it difficult to modify without affecting other classes. Let's take an example of a circle and a shape class. So circle class inheritance inherits from shape class, in which if we want to change the area of a circle by using different formula, we cannot do it because the circle class is tightly relying on the inheritance hierarchy. Making changes to circle class would require changes to shape class as well, potentially affecting other in the code. So we also have a problem called overuse inheritance. So overusing inheritance can lead to complex and hard to maintain code. For that, we have an example here. As you can see, that one parent class, the superclass, is inherited to many other subclasses. So when we are working on a step-based project, like we did in bank program initially and the splash kit program, the game program initially in our course. So using different steps and doing the program, and if we overuse the inheritance in our programs, then this as the system grows, maintaining such hierarchy becomes increasingly complex, especially when dealing with classes that have specific requirements. So overuse of inheritance in this case results in the code result the code too hard to understand, modify, or extend. Moving to our last problem, which is diamond problem, the famous problem for multiple inheritance that basically arises when a class inheritance inherits from two classes that have same method or attributes, leading to ambiguity in a program. As you can see in this example, that where that in a class inherits from two classes that two other classes. As you can see that we have A, B, C, D, four classes, in which D class inherits from B and C. So there is an ambiguity with display method to call from A. So this is known as a diamond problem and can lead to unexpected behavior and complexities in a code while running it. With this, I conclude my discussion here. Thank you.